GATE 2020 Metallurgical Engineering Question 53. In a top-gated mold, liquid metal enters the mold cavity as a freely falling stream under the gravity from a height of 0.5 meter. Ignore the fluid friction due to viscosity and the drag due to changes in the direction of the flow. If the flow of the mold cavity is 10 meter cube, the time required to fill the mold cavity is given. Acceleration due to gravity is 9.8 meter per second square. The cross-section area of the gate is 0.2 meter square. Now, since it is given that it is a top gated mold, so I am going to draw a simple mold gating design. Okay. Here, this is the mold cavity. This is the sprue and this is pouring basin. Okay. Here it is filled with liquid metal. If I assume the top surface of the liquid metal to be 1 and the mouth of the mold cavity to be 0.2. Okay. So two equations I am going to use in this equation. First is Bernoulli's equation and the second is the continuity equation. Fine. And let us assume that the height is h2 from the datum level. Okay. And this height is h1 from the datum level. Applying Bernoulli's equation between point 1 and 2, I will get P1 by rho g, V1 square by 2g plus the datum head is your H1. At point 2, it will be P2 by rho g, that is static pressure head, V2 square by 2g, dynamic pressure head, and the datum head, H2. Okay. So, since point 1 is exposed to atmosphere, so pressure at point 1 will be atmospheric pressure. Likewise, at point 2 also the pressure will be atmospheric because it is open to atmosphere. So they both will be equal and it will be equal to atmospheric pressure. Point 1 is at the top surface, so it is assumed to be at rest. So velocity at point 1 will be assumed to be 0. Hence, the value of velocity at point 2 will be 2g h1 minus h2. Okay. Or v2 shall be under root 2g h1 minus h2. Now, putting the values h1 minus h2, since h1 minus h2 is nothing but 0.5 meter, it is the height through which the freely falling stream is entering the mold cavity. So it is 0.5 meter. So it will be under root 2. Acceleration due to gravity is given to be 9.8 meter per second square. h1 minus h2 is 0.5 meter. So that will give us under root 9.8 meter per second. Fine. Now we are required to find the time required to fill the mold cavity. So what is the volume flow rate? Volume flow rate, it is given as A2 into V2. Okay, that will be meter cube per second. Fine. What is A2? A2 is 0.2 meter square. V2 we just found under root 9.8 meter per second. So that will give us the volume flow rate. Time required to fill the mold cavity will be, what is the volume of the mold cavity? It is given to be 10 meter cube. Okay. And what is the volume flow rate? It is 0.2 under root 9.8 meter cube per second. Okay, so that will give us, it will take around 15.97 seconds. Okay, that is approximately 16 seconds. So 16 seconds is the answer. To know more about the gating design, please refer lecture 4, Manufacturing Processes, Casting and Joining by Professor Shona Kumar Chaudhary, Department of Mechanical Engineering, IIT Kanpur. Thank you.